for this 1.3, which says that show that this here is this is even for all positive integer values of n. So we want to play around with this thing so that we can show that it is even for all positive integer values of n. So essentially the goal there is to play around with this so that we can show that in the end it will be a product of an even number and something else, which we don't know what it is, but we know that any number multiplied by an even number, the result would be an even number. So just as an example, if I can take like 3, we know 3 is not an even number, but if I multiply it by an even number like 2, the result of it will be not negative, it will be 6, right? Or if I take 7, which is not an even number, if I multiply it by an even number like 4, I know the result is 28. So that's the kind of idea behind this question. So now let's apply that thinking to this here. So there is a bit of laws of exponents that we have to apply. So like I have 2 by 5 to the power of n minus 5 to the power of n plus 1 plus 5 to the power of n plus 2. So this already looks kind of the way I want it to look, but for this 5 to the power of n plus 1, I want to break it apart so that the 5 to the power of n can be on its own, and also the same thing here. So how do I do that? So here I already have 2 by 5 to the power of n minus, I know that if I have, let's just use a different color here. This is just for explanation purposes. If I have 5 to the power of n multiplied by 5 to the power of, let's just give something a number, to the power of 3. By laws of exponents, I know that if I'm multiplying here two numbers with the same base, which is 5 here, and their exponents like this, we would add the exponents because the same base is 5 here. So then the result would be 5 to the power n plus 3. So essentially what I have here is this form. So I want to play around with this form so that I can make it this form. So how do I dissociate this? Then I can see that if I say 5 to the power of n by 5 to the power of 1, which is just 5. Let me write a little 1 there for clarity. So by law of exponents, this to say 5 to the power of n plus 1 is the same as saying 5 to the power of n by 5 to the power of 1. I do the same thing here, so that would be 5 to the power of n by 5 squared, like that. So now if I look across these three terms, so I have this term here, I have this term here, and I have that term. If I look across these three terms, I can see there is a common factor here. The common factor that I can see here is 5 to the power of n, 5 to the power of n, 5 to the power of n. So essentially I can factor out throughout the whole thing, I can factor out 5 to the power of n as follows. So I can have 5 to the power of n outside of brackets, then inside brackets, if I factor out 5 to the power of n here, I would have 2 left. And then minus, this minus. And then if I factor out 5 to the power of n here, this goes away, and I have 5 to the power of 1, which is just 5. And then plus, if I factor out 5 to the power of n here, I would have 5 to the power of 2 remaining there. then I'm just going to work out the result from the brackets or from the parentheses to show that I can have, if I have an even number coming out of this, then I don't care what n is, whatever integer value is. Then if this is an even number, then I have shown that this thing is even. Yeah, so then that's 5 to the power of n. Of course, it's 2 minus 5 plus 5 squared, that's 25. If I say 2 minus 5 plus 25, that will give me 22. So it's 5 to the power of n by 22. I know that 22 is an even number because it's exactly divisible by 2. So I have an even number. So this is an even number. So I have an even number here multiplying this, whatever this is, depending on what n is. It says here n is going to be positive integer values. So if n is any positive integer value multiplied by this even number, then the overall result coming out of this will be an even number. Just like we showed in the beginning, that even if something is not even, but if I multiply it by an even number, then the result would be an even number. So this is how we demonstrate that.